Hola, hola. My name is Diego, and I am here today representing Autonomy Network. Today, I will start with a small autonomy shilling session, and then I will go into a small tutorial on how to use our newest tool, AutoStation, which is a no code solution to automate things on chain. After that, I will hand it over to James, who will talk about how you can create condition contracts and upload them into our automation app store. So let's get started with our shilling session. So, what is autonomy? Autonomy Network is an on chain automation protocol. Because blockchains are passive, you have to manually interact with them in order for them to do things. But with autonomy, you are able to automate anything on chain, that is, any functions on chain, without having the need to set up any infrastructure or servers. For example, you could create limit orders or stop losses on DEXes. You could automatically manage loan positions or really any type of positions. You could make recurring payments, create dynamic NFTs, or even autonomous NFTs. The use cases are endless because autonomy is fully generalized. That means you can automate any functions on chain. Now, obviously, there are a few other players that offer similar solutions, but with autonomy, we have a few key differences. Because of our infrastructure, we are able to provide faster and more reliable executions. That is, executions that happen in the same block or in the next block. We can also add into our automation flow off chain triggers and off chain actions. This feature is not live yet, but what this means is that you can trigger on chain events based on off chain conditions, and you could also make off chain actions based on chain conditions. You can think of it a little bit like connecting Zapier into the blockchain. You can create alerts or automate different workflows. Like, for example, you can update your accounting software if every time that you make an on-chain payment or anything really. Autonomy is also the only automation solution that is currently on EVM, Solana, and Cosm Wasm. And we are also currently working to create a more seamless experience when trying to automate things across ecosystems. You can learn more about autonomy by going into our website, autonomynetwork.io. And that is it for the shilling. So now let's jump into the AutoStation tutorial. Hey, welcome to the AutoStation tutorial. This is the AutoStation frontend, and you can access it by going to autostation.io. So what AutoStation is, it is a tool for you to automate anything on chain without the need to know how to code. AutoStation essentially allows you to chain different actions and conditions, and you can think about AutoStation as being something similar, like if this then that for the blockchain. And so today we are just going to run through two very simple examples just to give you an idea about how this works. So we are going to first update a variable on a recurring basis. Very simple. We'll look at this through Polygon scan, and the second example is going to be a little bit more interesting, but it's also very simple, so that you are able to see how the upload mechanic works. Currently, we are only on Polygon mainnet and Polygon testnet, but if you guys have any requests for any other chains, just ping us on Discord, and we can add them in like 20 minutes for any other chain that you might need. But anyways, we connect our MetaMask and we land on this page. But before we create our first automation, we have to go to the Manage tab, and we have to deposit some Matic. We have to deposit so that these automations can occur on our behalf. And so I already deposited, so I don't need to do it again. I can go back to the automate page and create my first automation. But first, let's look at the contract that we are going to automate. And it is this mock target. It's a very simple contract. It only has an increment function, a decrement function, and you can get the count. So currently the count for this contract is 3. So we want to update that on a recurring basis. And so we will go to the front end again and create the automation. So it first asks us to add a name. So we'll do my first automation. And as I said, we are going to do this on a recurring basis. So yes, I want this to be a recurring automation. And let's start with, we can switch between condition and action. And so let's start with a condition first. And so it's going to be a time condition. Here we can pick between one-time automation, or we can do a recurring automation. which is what we want. And we can start this automation by current time. So October 7, 9:33, few hours before the hackathon. Anyways, we can also pick when we want it to recur. I'm going to pick custom, and I'm going to pick a very short time period. So that's 100 milliseconds. So it's very short, and this one's done. And now we want to do an action. I'm going to pick custom action. Um, but actually you don't have to pick a custom action. There's other sort of things that you could use if you like. We curate some of these actions, but if you untick that, then you should be able to see other actions that people have uploaded. But anyways, we're going to use this custom action, and we are going to automate this mock target contract. And so we paste the address, and we should be able to pick any functions that we want. So I will pick now increment counter. So we started at 3. Remember that. And we are ready to automate this. We approve the transaction, and we wait. Now the transaction has been approved, and we can go and check. This is the address for the Autonomy registry where all the transactions go. And we can see that one of these requests is ours. And if we go back and reset this, we should get that the counter has increased, and then it'll probably increase in a very shortly again. Let's see. And so yeah, took a little bit to update, but as you can see, it just keeps increasing and so on. So in order to stop this, we don't want this to continue recurring. We can go to the Manage tab, and we'll see the automation that we made. It has a name and everything. And if we click on the trash bin, we can cancel it, and then it will stop recurring. As we can see, we don't have any more open automations. That means that our automation is canceled and it's no longer recurring. And now we can move on to our next example, where we are going to modify the URI of an ERC 721. So this is the ERC 721. It's pretty simple. It has a few modifications, but that's not important. What's important is that we are going to change this token URI. Basically, I already minted the token number 0, and this is the string that it contains. So basically, this is the NFT that or the picture that it has an EV. And yeah, so in order to do that, we are going to upload a contract that I have already verified. The contract is this one. It's a URI modifier. It would basically be classified as a action contract. So it's pretty simple. You just set the new URI, and you set the target address that you want to modify, and it will just do it. And so we can go back here, and we are actually going to upload this and then use it on our automation. So we can call this URI modifier, and we can describe the conditions. Or sorry, this is not a condition, this is an action. So it's a URI modifier, and describe the action modifies a URI. And then the contract for this is this one, and function is change URI. Pretty simple. We upload it. We have to approve that transaction. And the transaction has been approved. And so we can go back into the automate page. Now we can call it whatever we want, modified NFT. And yes, so we will call an action. And so currently we are curating for just the ones that actions or conditions that the autonomy team has made, or the custom. But if we untick this, we should be able to see anyone that like any actions or conditions that anyone has uploaded. So here we can see that the URI modifier is here, and we can use it. So we just need to plug in a new URI, And so I will plug this URI, and here I will plug the address of the NFT, the target address. We can set a condition. So for example, let's say we wanted to wait 5 minutes from now. And so we'll just do the current time. Uh, sorry, we want this to execute in 5 minutes and before, I don't know, like 11 p.m. or a.m., sorry. And done. So we are now able to automate this. And the transaction has been included. And because we automated these, in 5 minutes from now, nothing has changed yet. So we can query this and it's still the same. Let's try one more time. Query token 0. Yeah, still the same. So we'll be back in a few minutes. Now it's 9:50 and we can see that our request has executed. And so if we go and reset this, we can see now if we query these, we have this new base URI. And if we plug it in, we can see that it has evolved to an Umbrian. And so, yeah, that is it for the AutoStation tutorial. We hope this is a very new product, so we're still improving. And if you guys have any comments, criticism, just message us on Discord, and we hope that you guys will build some cool stuff with this. And yeah, now I will hand it over to James so that he can teach you a little bit more about how to create condition contracts and so on. Thank you.
Hello. All right, so welcome to this tutorial on how to create a condition contract and upload it to AutoHedge. The full tutorial is already available on the documentation, but this is just like a video version just to go through like a live working example, live coding. And yeah, so by the end of it, we'll have created a condition contract, having uploaded it to AutoStation, and yeah, anyone will be able to use this contract to add time-based conditions. So this condition specifically is for adding two kinds of conditions, both time-based. The first is for a non-recurring, just single use. I want this to happen at this time, and the second is for more appropriate for like recurring conditions or recurring automation. Like I want this to start executing at this time, June 1st at 10 a.m. and then every day after that, I want it to execute. So for the very start, I mean, all the code is online if you want to see the kind of finished example. But we're just going to create a new file just to go through the motions. And so we're just going to create initially an empty contract. So you're starting off with a completely empty contract, time conditions, or time conditions 2 as we've called it now. And so for the very first condition, just being able to just wanting to automate something so that it happens at a particular time. With autonomy in general, like the way that you automate something is by enforcing it with a require statement. So we need to be able to create a function that, when called, will always revert when we don't want it to execute. And so we can do that with require statements. So let's do, we need to define a start time and an end time. Doesn't need to return anything. And so like this first part for just a single use is just like super simple. We want the block.timestamp, i.e. like the time that it executes, to be always more than or equal to the start time and less than or equal to the end time. That means that if somebody tries to attempt to execute the request, the automation request outside of these bounds, it will revert. And actually, that's the way that the autonomy bots know whether something is executable, whether the condition is fulfilled. They essentially locally simulate if executing this request will succeed or revert. And so if it does not revert, that means that, by definition, whatever the condition is now like fulfilled, and so they should like broadcast the transaction. And so that's pretty much it for like the first part between these two times. So like a transaction will call this function between times, and whatever other action that you want to automate. So that the kind of logic flow here is there's a diagram somewhere. Here, so you initially make the request to the autonomy registry, and there's what's called a funds router contract. So the autonomy registry is general for any just automating literally any on-chain condition, any on-chain action with any on-chain condition. And the funds router is the kind of the main contract of AutoStation specifically, like as a kind of separate product that's built on top of autonomy. And so what the funds router essentially does is it allows you to do three things, which is deposit ETH so that you can pay for the execution fee, because autonomy requires you to pay the execution fee to cover the gas cost of the bot who executed it. So it allows you to deposit ETH, withdraw ETH, and then route calls through it. And so, for example, in the case that we're creating this time conditions contract, in the kind of like bonus section, it goes through this example of like how to actually create a request that does this. It's not. I'm not going to go through on this video tutorial, but it's there if you want to check it out. It gives you extra context of like how exactly these things are all tied together and how the actual transaction is made, which I think gives a deeper understanding of the system. But anyway, you essentially ask the registry to call funds router, and in funds router, I'll just show it here very quickly. In funds router, I said we deposit ETH, withdraw ETH, and this third function called forward calls. Now, it doesn't really matter like what is in the body of this function, but basically like you ask it to call other contracts, and we see here that this essentially just like gets the target contract that you specify and calls it with the call data that you specify, kind of like the registry. And the reason this is important is because you can then just like string together arbitrarily many contract calls, and because they all happen within the same transaction, time conditions and mark target. Mark target is just like a dummy contract where it has like a variable X that you can increment. If the time condition if the time condition itself is invalid and reverts, it means that the whole transaction reverts. And so if you want to be able to increment X, like some variable in some mock target contract, you need to use the time conditions contract as the obviously the time condition with an action to perform the action every 5 minutes or whatever you set the time condition to. So that's a little bit about how it works. And so you'll essentially ask the funds router to call between times if you are wanting to do it just once. But in the case of a recurring automation, we want to call it many times, like starting from some time period and then like every at some time and every time period after. Cut here. Okay, start again. Okay, so for starting off this like recurring condition, we need to be able to specify a start time and a period length. So the start time, it's in Unix time, both of them are in seconds. So whatever the Unix time of like right now is, we could use that as a start time, for example. And so that we would require that the current time, when executing, is always greater or equal to the start time. Otherwise, it should revert. But we have an issue here, which is that when using the time period, we need to know which cycle we're on, because if we start at like time t equals like 10, and we want the period length to be like 5. We want to execute once at t equals 10, once at t equals 15, and once at t equals 20. And if t equals, say, like 18, if we don't know when the last time we've executed is, then it's impossible to know whether a full period has elapsed or not. And so we can essentially like save the last execution time, last exec time. And so pause here. I guess that's good. So we can say if last exec time is equal to 0, i.e. this is like the first the first time that this has been executed, then require that obviously the timestamp is past the start time, but also we need to actually like save the last exec time as now. Equals block dot time. Oops. And so if we're now on one of the further periods, then we need to require that block dot timestamp is greater or equal to well, we need to know what the next time period, the next Unix time that we need to execute at. So equals the last exec time plus period length. And so if this is not the first time, then we're requiring that obviously like this is one period after the last executed time. And then obviously we need to save this as the last executed time. I cannot spell today. Pause. And pause. So if there was only one person using this contract, it would basically be done. Although not even if one person, if there was only one request, like one thing being automated on Autonomy that used this contract, then it would basically be done. But we don't want to have to deploy a new contract for every time we want to automate something. Like the whole point of AutoStation's kind of architecture is the modularity. The fact that once a time conditions contract exists and is listed in the system, then anyone can mix and match it with any other condition or action. And so we want many people to be able to use this contract. So obviously, if multiple people were using it, then people would kind of conflict and like affect the last exec time for each other. So we basically need a way of differentiating the last exec time for different requests. And so the way we can do that is with a double mapping. And so the ideal thing here would be if we're able to just map directly once from the request ID to the last exec time of that request. Autonomy doesn't have that feature at the moment. It's coming up in a new release soon. But for the time being, we have a workaround, which is that we're able to know the user that made the request, and each user can just pick a call ID or whatever you want to call it, like the kind of their own kind of internal like request ID. And so like effectively, if we're able to know who the original user is, people can't like mess with each other's requests essentially. So in order to apply this, instead of last exec time, well, first of all, we need to know who the user is. And so we can put address user and call ID. And the reason I put it in the function input is that anyone could just call this function with any user they want, and if they were able to use the mapping for like someone else's user, obviously that would like screw with other people's automation. But Autonomy has this feature, it's described in the documentation, called verify user. When making a new request, it's one of the flags. Actually, I'll just like very quickly show you for reference. So the new rec is the function to make a new request, and verify user is one of the flags that you can input. And essentially what this does is this guarantees that like the registry checks and guarantees that whatever the first argument of the function being called is, it's not in the registry, it's in the funds router. This is kind of a bit deeper than we need to go, but basically when you're asking the funds router to forward calls, you can tell it whether for it to do the thing that I was describing that the registry also does, but the funds router also does, which is to verify the user, i.e. force the first argument of the function to be the user, so that this function knows who the original user is. And what the funds router and registry also do when that flag is true is that they route all requests through a forwarder, and the forwarder essentially just it just acts as like a middleman in between the funds router and the time conditions contract. And so that the only time that a call will come from the funds route, from the forwarder, is when the verified user flag is true. If a call does not come from it, then you cannot trust that this user has been like verified by the funds router. And so we essentially just need to require that message.sender equals included it here. The router, what this means is like the router, like the funds router, is user verified, and it's a forwarder. So it's a forwarder that has verified the user. So that essentially means that whenever we know that the only time that this function can be called is when it's being called from this forwarder, and the only time that the forwarder is calling this contract is when the funds router has guaranteed that the first argument is the user. So I'll pause here. On pause here. So we can basically just switch out last exec time for this mapping that maps like the user to the quality, etc. And so every single request will be separated. This, and we need to save it. Save the current execute time. Pause it. On pause here. And so, by the way, obviously, because we added this variable that is like permanent and never changes, obviously we need to add like add a constructor. So it's best practice to put it at the top, and these state variables should also go at the top. And there you have it. I mean, that's pretty much done. So now this function, every time period, every time that some transaction or anytime it's part of a transaction, it guarantees that the whole transaction will revert unless it's past the start time. And if it's already past the start time, then it needs to make sure that that at least one period length has elapsed since the last executed time. So we can now deploy this to AutoStation. So AutoStation, you can just like automate things using other these conditions that people have uploaded, such as these like mock actions, or for conditions. We see the recurring time condition here that someone's already uploaded. But anyway, say that we wanted to upload this ourselves. There's not much point uploading the time conditions contract again because someone's already uploaded it and everyone can just reuse the same contract, which is kind of the whole point of the modularity of AutoStation. But say nobody had already created it, then, well, first of all, we'd need to deploy it. And if you look in the repo, like the link is in the documentation in the tutorial, there is a deploy script. And by the way, this whole repo uses Brownie to do all the tests and also the deployment. It's not like a huge deal if you are not familiar with Brownie, but basically you just want to run this command like install Brownie, and you can just run this yourself. It requires that you've exported like a private key called deploy priv to, or I think actually it's deploy priv in the original repo. But anyway, and you also need to publish the source code. So you need to have a Polygon token exported. I can't show you exactly, like, because obviously I don't want to show the key, but it's deploying. It's not a huge deal. But in order to be able to upload it, the code does need to be verified. But I mean, you can verify the code through other ways anyway. So we want to actually before I do that. I don't want to, this is for deploying like the whole system, and we don't want to do that. We just want to deploy the time conditions contract here. So I can run deploy, oops. By the way, pause here, I made a mistake in this. I'm just going to comment it. Come on, brain. What was it doing? I need the address. All right, on pause here. So I'm just gonna, like we had, we need this like forwarder address for Polygon. I'm just kind of hard coding it here. All the deployed contracts addresses are in the documentation. So we should be ready to roll. Alrighty, so the contract took some time to verify, but it is deployed and verified. So now we can head to AutoStation and hit upload. So we're gonna call it. You have to upload each condition individually, and so because we uploaded two, because the contract has two, we need to essentially do this twice. But for just doing the first. So between times, execute between two times, and paste the address. And because we verified it, the UI is able to get the function names. And yeah, it's just one transaction to upload this, to make a note like on chain. And that's it. So yeah, we've uploaded the condition and now anyone can use it, and that's pretty much it. Cheers guys.